All right, so this is chapter 13-5, and it's pretty much a review of chapter 10. So if you didn't get things in chapter 10, here's your time to really fix the mistakes that you made from chapter 10. So step one, first things first, we have to decide, since there's a variable in the denominator, we have certain restrictions. So what would the restrictions be here? Yes, Jordan. X cannot equal 0.
X cannot equal 1.
So in this case, x cannot equal 1 or 0?
1.
1 only, because 1 would give us a 0 in the denominator. Great answer for your birthday. Happy birthday, Jordan, on the recording. Going to be popular on YouTube. All right. Shh. So, you guys should know how to solve this by now. Go. Pause the recording and solve the problem. So, Alexander, what would you do first?
So first, you multiply everything by x minus 1 over x minus 1, just x. To get
Well,
rid of the denominator.
actually, since these are both two fractions, how did I teach you guys to do it? Do cross products. Okay, when we do our cross products, here's the danger with doing it the way you did it. We'll get to that afterwards, but I'm going to come back to that way. So when I do this, I get x times x minus 1 and 2 times x minus 1, and then we distribute. And what we have here is a quadratic. I combine my like terms, right? And now I've got a trinomial. We can either factor, use quadratic formula, or complete the square. What's the easiest method? I think factoring. You can complete the square. It works every time, but I more so tend to do that when I have a lead coefficient, because I hate lead coefficient factoring. So I'm going to factor what multiplies to 2 and adds to negative 3. Yes? Good. And then my solutions are 1 and 2. Now, are both of those answers viable? No. We see that x is equal to 2. So, in this situation, 1 doesn't satisfy the restriction, so we only get 2. Yes, question?
Couldn't you divide, once you got x times quantity of x minus 1 equals 2 times the quantity of x minus 1, couldn't you divide both sides by x minus 1?
You could, because we're using properties of equality, right? We can do anything. So she's asking, which is kind of in line by just clearing x equals 2 over x minus 1, which is what Alexander was talking about, actually from the get-go, multiplying everything by x minus 1. And then what happens is we're just left with x equals 2. But what you're running the risk is of not getting that second solution. Yeah. And the same thing's happening there. If you see, as soon as you see this, it's a quadratic, you are likely to have a second solution. Now, will it always be part of the restriction? I don't know. So you're just running the risk of not seeing that. In this particular case, it worked out. Okay, now, what's my restriction here? Adam? Cannot equal.
Cannot equal 0.
0. Good. Okay, you guys solve the next equation. Go. Pause the recording. McKenna, what would I do first?
So what I do first is I multiply both sides by x to get rid of my denominator.
Good. Multiply both sides by x to get rid of the denominator, and what do I get?
You have
X squared
plus 5
plus 5
equals 6x.
equals 6x.
Yeah.
Okay, and then
You would subtract 6x. Get x squared plus 5 minus 6x equals 0.
x squared minus 6x plus 5 equals 0. So put it in standard form.
And then it would be, and then you would factor it to x minus 1
What multiplies to 5 and adds to negative 6?
is negative 5 and negative 1
Shh. So we are doing x minus 5, x minus 1,
equals 0, and so your solution is
5 and 1. Okay, questions there? Okay, any questions? All right, Next one. Pause the recording. Start this one. What, before you pause it, what are my restrictions? Kendall?
6 and 0.
6 and 0. Excellent. Okay, go. So, what is the least common denominator, Kendall? Shh.
X minus 6.
Times
X.
x. We need the x, and we need the x minus 6. Because I can't just try and multiply this. I can't just try and multiply this by x minus 6, because I can't take a piece of a binomial to cancel. Does that make sense?
Yeah.
The only thing I can cancel with an x minus 6 is another x minus 6. So now, Kendall, when I distribute here, what gets canceled out? What can I cross cancel? What's exactly the same? The x. So what's left? What? What's left?
X minus 6.
Times? Perfect. Next time, Kendall and Kendall only. Thank you, everybody, for the help. But this time, when I distribute the next time, shh. Okay? Here, what's going to get canceled out, Kendall?
X minus 6.
And so what would be left?
X times X minus 6.
Good. And then next time, Malcolm, when I distribute the last time,
You're going to have the x's canceled out, so it's 4 times x minus 6.
okay, next step, Kendall, what do I do here?
Multiply.
Good. And it becomes?
X squared. Minus 2x minus 6x plus 12.
Good. And over here? Over here, keep going.
X squared.
What kind of x squared?
Negative.
Yep, negative x squared. Keep going.
Plus 3x.
Plus 3x equals?
4x minus 24.
Good. Now on this side, I'm going to combine my like terms. I've got x squared and minus x squared. So don't they cancel out? Okay, I have negative 2x and negative 6x. And that makes negative 8x and 3x. What does that equal to? Negative 5x, and I have a 12. Equals, so I've got that, and that 12 equals 4x minus 24. Next step, Kendall.
Subtract 12.
Okay, negative 5x equals 4x, and then minus 36. Keep going.
Subtract 4x.
Did you forget to do that, Chris?
What?
Seems like this is where your step went wrong.
I got 7x equals negative 36.
Make negative 9x equals negative 36. Keep going. What am I doing next, Logan?
Divide by negative 9.
Good. And so what is my answer? X is equal to?
4.
Okay. One solution. I don't know how you got 5 9s, but I would think that right here you forgot.
Negative 37.
Okay. Shh. All right. So remember, shh. Guys, I'm recording, please. So remember you need both to clear. Okay? Okay, let's look at the next one. Okay, go. Don't forget about your restrictions. Put it on pause. All right, now check your work. Remember, we've got to double distribute. The first time I canceled, and you should have had this. And then we factor out the negative 2x, set them both equal to 0. Shh. And so my solutions are x equals 0 and x equals negative 2. Do they both work with the restriction? So that is the solution. Okay.
I got 0 and positive.
You got 0 and positive 2?
I got rad 5.
Shh. Hold on. Quiet. Shh.
On that step, I divided it all by 2.
Okay, so if I do that, shh. So here, when I have, excuse me, negative 2x squared minus 4x equals 0. Divide by negative 2, divide by negative 2. So what we get is x squared plus 2x. 2x squared, right? Equals 0. No. I get x squared, not 2x here. Right? And then we can factor out an x times x plus 2 equals 0. And here, x plus 2 equals 0. X has to equal negative 2 here.
He did it on a different step.
Oh, you did? Where'd you do it?
On the negative 2x squared plus 2 equals 4x plus 2.
Shh.
I did it from that.
Right here?
No, on the other side.
On the other side of x.
Oh, over here.
Yes.
Yeah.
Okay, that's kind of, you haven't combined all your, you don't divide out a common factor till you get rid of, you combine all like terms. So you've got that, you kind of want to put everything, shh, can you guys stop? I'm recording. Okay. All right, let's look at the next one. So in this case, remember, we can't take a piece of the binomial x to just clear the x. So we need to multiply by both. Is that clear? Now, sometimes you're going to get here, and we end up with lead coefficient factoring, right? So this is your chance. My suggestion is you mix it up. What makes this different from chapter 10 is you have the choice. Oh, wait, do not pack up. You have the choice to factor, use the quadratic formula, or complete the square or square root method. Well, here we can't use the square root method. So mix up your practice. Do you understand? We can find our A, B, and C and plug it into the quadratic formula. Let's look at 2 more. I just asked you not to pack up until I asked you to. So although they're factoring here, I don't enjoy doing lead coefficient factoring. That's when I would use the quadratic formula. When you have something like this, Kendall, you with me? Chris? Okay, when you have something like this, remember, before we can clear, we need to factor right here. Minus x and this, we need to see what the factors are. That's an x times x plus 2. So that way I know to clear by x times x plus 2. Does that make sense? Another example of that would be right here. Although my PowerPoint is solving everything by graphing, another example would be this right here. Notice when we have a difference of squares, make sure you break that down to x plus 2, x minus 2. Now you know what you truly have to clear. Okay, are there any questions? All right.